Right, the numbers appear to be fairly steady now, so I think we'll get started. So good morning, everyone. I'm John Saltmarsh. I'm the Chief Technology Officer at Energy Systems Catapult. Thank you for joining the launch webinar of our new Net Zero Data Service. Really great that you could join us today. We see Net Zero Data as the gold standard for the detail and quality of data you need to undertake local area energy planning. And we're really glad now that we've been able to launch an API that allows you to get automatic access to the most up-to-date versions of your data when you need it. But more of that in a moment. Can I start by just moving on to housekeeping? So I've gone to the next slide. The session's being recorded and we're going to place it on our website. The great advantage of the fact you're here today is you get first sight of it and the opportunity to ask some questions in a live environment. Please keep microphones off for obvious reasons. And we also find that keeping cameras off avoids overloading the network. So unless you're speaking, can you keep your cameras off? Makes it easier for all. And finally, please put any questions into the chat. We'll try to answer them in line as we go on, and we'll pull some of them out to talk to at the end. So that's the plan there, but please do come up with any questions as we're going along. Have the next slide, please. By way of background, Energy Systems Catapult is one of 9 catapults. They're set up by the government. We've just celebrated our 10th year anniversary. They've been set up to accelerate innovation and drive growth in key sectors of the economy. Generally the industrial strategy sectors, things like high value manufacturing, digital, space, cell and gene therapy. And we focus on energy systems, how we transform the energy sector to make it fit for the 21st century and beyond. We're a private, not-for-profit company, and we're focused on supporting innovators and doing the difficult stuff that needs to be done once as we accelerate the energy system transformation to meet the net zero and an energy system fit for the future. Net zero data was developed as a go-to source of data for those undertaking local area energy planning, specifically of stage 1 to 3 of a local area energy plan. We launched the data product last year, and it's been very successful in terms of a lot of local authorities and consultants and people are now buying the data to use within local area plans that they're producing. But the Net Zero Data API provides a broader scope for using our data, because you can specifically select buildings or locations and get it automatically downloaded to give you a granular insight, but also avoid some of the royalty costs when you're not buying data for a region. This makes the data much more cost effective for those organisations that don't qualify for the PSGA Ordnance Survey licensing. And we'll talk more about that in detail in a moment. But let's just move on to the next slide and the agenda for today. It's set out on the screen here. You'll be hearing from Sandeep on an overview of what we've developed. Then I'm delighted that we've got 2 innovators who we've been working with to develop the functionality, Jonathan Coyles from Barker Associates and Jody Bigwood from EnviroGood. And they're going to be talking to us a little bit about how they've been using it and how it works for them. Then Ailey will come on and talk you through a bit more of the technical details and how the API works in practice. And finally, depending on how we go, I hope we'll have some time for questions at the end. At the end of each speaker, we'll be having a quick poll. It should come up automatically on the screen. We'll also put it on the chat, and just interested in getting some feedback as we go along. So that's the introduction. Without further ado, I'll hand over to Sandeep. So Sandeep, thank you.
That's one. Thank you, John. Good morning, everyone. Tabitha, can we, if you hit the next slide again, please. Cool. So there's a number of bullets on screen, some challenges that I've outlined, and how many of you can relate to these challenges? Around data availability. There's lots of data sources out there in the market, and it's not really clear where the data is located and what data is available and kind of the quality, etc., of that data, which can make project planning and sort of identifying opportunities a bit more challenging, because unless you have exactly what you need in an easy, accessible way, it makes identifying those sort of opportunities challenging, because you sort of lack a complete picture. Data accuracy and completeness. There are some very, very good data sets out there, both open and commercial, but it's one of the biggest sort of challenges with open data is that they may not be actively maintained, or they were developed as a one-off. And there are data sets out there and data sources out there that may just have gaps within them, which can limit what they can and can't be used for. And there's a significant gap in modeled energy data, which is a gap that we're trying to fill with Net Zero Data. The challenges around cost. There's complex licensing frameworks, complicated terms and conditions. Both of those sorts of things can make procuring data quite costly. And with Net Zero Data, we've made those things simple and the data more affordable. So you only buy the data for the area that you need, or data for use cases that are relevant to your business or your clients and their needs. So you don't need to buy a license that, for example, covers the entirety of the nation, or you don't need to integrate or align with multiple licenses from multiple different suppliers. And making data usable does require a significant amount of skill and knowledge to specify the data you need, know where to get it, know how to validate and procure that data, which adds an additional overhead to your internal teams. And your internal team should be using data to gain insights, rather than spending time building the data before they can sort of get to the point where they can start pulling out insights. And then finally, integration and sort of data maintenance, right? Integrating with internal tools is not always an easy task, especially when you're dealing with a myriad and a varied sort of broad scope of data sources and data sets. There's generally quite a lot of effort that's needed to kind of merge multiple data sources, standardize schemas, and get them in a shape where the data is actually usable, and therefore ultimately adding to the cost of decision making, whether it's a cost on time or a cost from a resource perspective. And then maintenance, right? Customers don't really want to have to continually maintain data themselves. It's an additional overhead that a lot of people don't consider. So next slide, please. So with Net Zero Data, the product that we developed that John sort of very high level sort of summarized was, it's a product that consists of a suite of data sets and data bundles that enables you to quickly assess the energy landscape in a region and find potential project locations and progress to next steps sooner, whether it's project planning, prospecting, deeper feasibility assessments, or full-scale project planning, such as the LEAP. And through Net Zero Data, we're addressing those challenges and solving some of those problems that I've highlighted on the previous slide. Next slide, please. So the wider suite of Net Zero Data datasets, they've been developed in a way that align to net zero themes around renewables and storage, heat, transport, and buildings and energy demand. And the first three themes on this slide show you the potential for opportunities, which ultimately answer the common questions that people are asking, right? Where are the best large-scale renewable locations? Or, in my portfolio of buildings, which would benefit the most from low-carbon heat solutions or rooftop PV? Or where are the best locations for solar carports, for example, right? So those first three themes just give you answers to those common questions that you simply just need answers to really quickly. And then the final theme at the end is around buildings and energy demands, right? Using model data that can help answer questions around, well, which buildings in my portfolio have the highest energy demand, and therefore, which should I prioritize first? And Net Zero Data has been developed with full GB coverage, right, across all data sets and across all of these themes. And until now, it's only been possible to purchase data by local authority region or by postcode sector level, which, as John called out, can have a higher cost implication if you're not buying data for public sector purposes. If you're not buying the data under PSGA membership, Ordnance Survey's PSGA membership or licensing. And that higher cost is due to the fact that the commercial royalties are payable on each building point or polygon within the data. And these are Ordnance Survey royalties that are due. So, if you're a commercial organization and you buy the data by the region, but you only need a small subset of that data, our current historic model was you could only buy by the region. So therefore you end up paying for royalties on data that you're never going to use. Next slide, please. So the API, the benefits of the API give you that instant insights. So it enables you to save time and resources with using ready-to-use data that, as I said, covers the whole of GB. You can quickly identify projects and those opportunities that are relevant to your needs and your client needs. There's no additional noise and additional cost from data that you don't actually need. Thanks to the API, you're able to, as John said, target specific buildings or portfolios of buildings or land parcels. And the simple cost structure that we've developed for the API, and the simple means of accessing the data just enables you to move forward with that cost reduction and time reduction. Make prioritization and decision-making processes quicker, identify opportunities in existing portfolios with ease, plan new or existing projects more effectively, and find new market opportunities, outside of what you would typically do potentially. And then flexible access to data, right? You get access to that regularly updated data as and when you need it. Next slide, please. So how would you sort of use the API, and how would you integrate it into sort of complex workflows? At the top in orange, we've got use cases. So, the API can be used to support you with your portfolio assessments, find opportunities for low carbon tech and interventions. Or you can draw insights either at the regional or national level, to help inform, how your opportunities might feed into, a much larger scope. And you can do a lot more as well. With regards to API inputs, these can either be user-defined in your application or a predefined set of inputs, depending on how you want to integrate and how you intend to query the data. And your inputs can then be used in the API to either run individual dataset queries or build multi-step data queries. So results from one dataset can be used to interrogate others, which can allow you to kind of turn that raw data into actionable opportunities and insights. And then your outputs, your data can be simply outputted as a list of potential opportunities, or you could process those outputs further and feed them into a dashboard, or integrate them directly into your systems and tools, whether they're internal or customer facing. Next slide, please. And so with the API access, spend less time, finding, sorting, cleansing, and processing data. Just do more from day one, and that's what the intention with the API is to enable you to do. Data access is handled through a credit model, which means you buy a block of API credits, and each row of data returned from the API uses credits. Authentication is all handled through the API, which is done via API keys. So we're not doing anything that's not sort of standard or unconventional. And you're in charge of those API keys. You generate them yourself once you're onboarded. Pricing. Our pricing starts from £1,000 ex-VAT a year for API access, which is effectively starting from around £83 a month. And for more detail on our sort of pricing tiers and API tiers and pricing, I'd recommend you visit our online marketplace where you can register and get more information around the tiers and pricing. And we have got a mixed blend of organizations on the session today. So for those that don't have an in-house tech team, but you do need specific data, but you don't necessarily have the ability to integrate with our API, please speak to us. You know, we do offer a data extraction service that we'd be happy to discuss in more detail offline after the session. Next slide, please. And looking forward, you know, our work doesn't stop here. We're always enhancing net zero data. If you do have challenges, use cases, or needs that data can help with, we'd love to hear from you to see how your inputs and your insights can help inform our roadmap. And if you'd like any more info post this session, please reach out and we'll be happy to help. I'll now hand back to John. Thank you.
Brilliant. Thanks very much, Sandy. Right, so we've now got our first audience poll. So the question here is, what net zero data domains are you interested in? And select one or more of the following options: buildings, land and transport. So hopefully you can click on those, press submit, and we'll be sharing the results later, I believe. So moving on. The first case study, I'm delighted to introduce Jonathan Coyles. He's a partner at Barker Associates. And Jonathan, over to you.
Thanks very much. And thanks, Sandeep, for that overview. So what I'm going to do is give an overview of who Barker are and what we do, and how we've been using the data and how we're looking to integrate further into the API that Sandeep talked about. So Barker is a small consultancy, 120 people, 4 offices across the UK. But I think one of the innovation things we have is we have our own data platform to sit alongside the work we deliver. So we have a data portal built on Power BI called the EO Portal, which helps us manage data in the long term. And what we found exciting about working with the Energy Catapult is how that data that they have matches and helps us deliver projects for our clients. The exciting project that we've been working on in the last couple of years is the DfE Net Zero Accelerator Programme. And if we could just look at the next slide, which goes into what we've been doing. So what we've been looking at over the last few months and over the last 12 months is looking at 25 schools where we've been looking at doing a whole range of different interventions, and we've been taking the sort of base data that the Catapult team provides us with and seeing, well, actually, what can we do to reduce the carbon footprint of those buildings? And what we've been working towards is delivering in over 6 months a 20% saving in the energy consumption of those buildings against the baseline that we started working with from the Catapult data. And what we're then doing is feeding that back in. So where there's air source heat pump projects designed in Energy Catapult data, or a PV project, we're giving the feedback and saying, well, okay, the theoretical data says this, but actually when you get to site, these are the sort of challenges that you may face, and we're then feeding back that data in to help in that journey. And it's been really exciting to see what the theory says into what the reality of decarbonising public buildings has been. We're now working on the next phase, which is the GB Energy Solar Energy Partnership Programme, which is putting PV onto 47 schools in the northwest of England. And again, what we're doing with that data set is building into what the Energy Catapult data shows us, and then moving that forward to see what that could mean. And what we're doing is going in actually delivering projects, and so far, which on the next slide, it shows you some of the projects we've been delivering. So across the 25 schools that we've gone on and delivered, we looked at 29 specific projects. Can we just look at the next slide, please? Sorry, which we're looking at EV charging, we're looking at solar PV, we're looking at LED lighting and controls optimization, and the interventions we've identified are going to save £1.2 million over the next 10 years, which it has been a real impact in those small schools which may not have had those interventions. But again, the great opportunity for us is as we go into the 47 that we're doing next, is that we haven't had to go and collect a lot of that base data in the first instance. We've got a baseline to work with from the Energy Catapult data to build out going forwards. And one of the models that we often have built theoretically ourselves has been working on PV, and the next slide looks at the sort of savings that we've built into the model of PV, and what we've done before we were working with the Catapult team is we'd worked on a 40 kilowatt PV array on a primary school and a 150 kilowatt PV array on a secondary. But working with Sandeep and the team, we were able to look at some more nuanced data about building type and archetype. We're looking at smaller sites in a bit more granularity, and it helps us build these models with a bit more informed knowledge before we start on that journey. And part of what we're trying to do is to get people to engage in the program. As you can see from this data, the investing in PV over 5,000 schools might cost about £360 million, which is an awful lot of money. But when you see the return on investment over 25 years, not allowing for energy price inflation, have been around about £1 billion, it builds up a great business case. But working with the Catapult team, it's going to speed up that process of building these business cases that are more relevant to the sites, and we're understanding the restrictions from the DNO infrastructure and all of those sort of things. But it's thinking about how you can speed up the decision-making process, but also evidence the savings are made, and that's where we're feeding back the data. So our real-time energy portal on the sites that we've been working with Sandeep on, we're giving the Energy Catapult team that real data to show the impact of the investment that we've worked on together. So that's just a bit of an overview of what we've been doing, and as I say, data is set at the heart of everything we've been doing. We're fairly, as I said, the portal that we have has been fairly unique over the last 5 years and got us to where we are, but we're going to enhance that by working with the API and pulling the data in and allowing us to compare theory against reality. Hopefully that will help everybody. Back over to you, John.
Brilliant. Thanks very much indeed, Jonathan. I do like £1 billion opportunities. It sounds like a fantastic challenge to tackle that. But we're on to poll number 2. What technology types are important to you? And there's a list there of different technology types. Please to put your answers in and click the submit button. And I will now move on to introducing our next speaker. So if we can have Jodie Bigwood, who is the Chief Executive at EnviroGood. Jodie, are you still there? You're not appearing on my screen.
Hi, John. I'm here, yes.
Brilliant. Fantastic. Hi, Jodie. Thanks.
Good morning,
Over
everybody.
to you.
Thank you very much. Could we move to the next slide, please? Good morning, everybody. I'm Jodie, the founder and CEO of EnviroGood Limited. We're a Leeds-based business. We're accelerating the transition to net zero, and we're developing some real-time solar planning and funding software, which we call our digital twin for buildings. Next slide, please. We are a Google-backed business, and the main driver that we are kind of set up and incepted by is that solar project stakeholders are really struggling to access the precise data for informed decision making, which is resulting in a lot of uncertainty over the real-world benefits and risks. Our solution to this is to provide a digital platform providing rapid bankable project data to reduce the project risk and enhance the investment appeal, specifically for commercial and industrial rooftop solar projects, along with blended energy solutions such as EV charge points and battery storage systems. We developed this tech using AI, but also collaborating with the Energy Systems Catapult for some live data sources, amongst other data sources, and also drone technology. So we're using photogrammetry to be able to assess and survey buildings to centimetre level accuracy. We're also accessing live data sources to be able to look at the potential usage benefits of solar and battery storage systems at these properties, along with other metrics that we're using to establish the commercial and environmental viability of solar at such properties. This solution is automating what is otherwise quite a manualized process and results in a lot of task repetition. Typically in the industry in the UK, there's about an 89% redesign rate for solar systems using the kind of traditional manual methods. And this is leading to about 68% of designed rooftop solar projects actually not moving forward to the kind of investment stage. So by automating a lot of the processes and by increasing the accuracy and efficiency along the way, we're able to reduce the design cost by around about 83% because of our increase in speed for the process. We're also, due to our increased accuracy, able to improve the amount of electricity that is saved on site due to the optimization of the layout of the modules, which is also born from some of the AI and the accuracy of the data that's coming from Energy Systems Catapult. And what this results in for project owners is an increased fundability, and also for funders themselves, reduced cost in terms of due diligence when looking at such projects. Next slide, please. The solution that we're putting together is at the moment a minimum viable product stage. We're just about to launch and test this product and feed those findings back through to Energy Systems Catapult for us to be able to further evolve, iterate and pivot to be able to address some of the challenges in the industry that I've previously alluded to. The four-stage process really that our software is looking to address these challenges with is initially a mapping stage. The mapping stage is where we're picking a particular region or a customer's particular region or a, say, portfolio of properties that they're looking to identify as which would be the most suitable for looking at potentially deploying solar and battery storage systems to. Therefore, we're accessing some of the data that's coming from the catapults to be able to determine the suitableness of these sites and to be able to perform our grading analysis. We also access other data sources. So therefore, the data that's coming from Energy Systems Catapult isn't just used as raw data, it's also used to validate other data sources to be able to have the confidence that is needed to be able to address some of these challenges that I'm discussing. Identifying sites is one thing from Google Earth kind of satellite imagery, but the accuracy of actually making that a constructible site and making construction-based drawings from that is pretty poor. Therefore, this is where our 3D drone-based photogrammetry technology comes in. We will deploy the drone using our network of drone operators in respective areas to fly on a predetermined flight path at a property and come up with a very accurate centimetre level 3D model with an optimized solar layout on the roof, and utilizing the data that's coming in from Energy Systems Catapult and other sources, such as connecting directly into the smart meter at the properties, we're able to very accurately come up with what the usage performance is likely to be for the lifetime of the system. This is then connected through to funders to be able to provide the funding mechanism, whether that be a PPA or a traditional financing package, with more assurance and a performance guarantee that the system is actually going to perform as it's supposed to for the first year. And thereafter, we're able to also monitor and offer flexibility services for systems that have been designed and installed using the Envirogood system. Next slide, please. A quick use case example of where the technology has been of great benefit that we wouldn't otherwise be able to potentially address is, say, a cherry farm where we've got polytunnels. There's variable energy usage across different seasons, and there are challenges that are needing to be addressed in terms of extending seasons due to introducing potentially HVAC measures into the polytunnels themselves. And some of the projects, unfortunately, relating to like cherry farm and agriculture, as well as the commercial and industrial building stock, obviously face the same challenges in terms of getting projects funded due to the inaccuracies and inefficiencies of the existing manual approaches. And this is compounded when you have kind of intricate sites such as, for example, polytunnels. If you could move to the next slide, please. Just to wrap up, the data requirements that we have as a business to be able to offer our planning and funding and validating elements are, as you can see on the screen. Some of these data requirements are coming through from the Energy Systems Catapult and enhances the work that is already being done by Google, who we're supported by, and also our software development team, Walt Labs. We offer our solution really for blended energy projects. It's not necessarily just a solar solution that our user would be looking at. It might be that they're looking at introducing additional measures such as electric vehicle charge points, and therefore the additional data that we get through from the Energy Systems Catapult to be able to cater for these blended energy projects is second to none. So if you could just move to the last slide, please. This is just an example of a actual building that has been completed after having flown the drone and completed a 3D virtualization. It might look like a photo of an installed solar system, but it's not. As you can see, it's addressing and assessing all the different elements connected to the performance of that building, overshading, obstacles on the roof, energy consumption, DNO local capacity, amongst many other things, of which the Energy Systems Catapult data is fundamental to us to being able to achieve this endpoint. So if you'd like to discuss this type of work with us for any potential projects that you have, feel free to make contact. Thank you for listening.
Jody, thank you very much. That was brilliant. And, you know, it's one of the things we feel really strongly about within the catapults is how we move from planning to action. And I think you're demonstrating there really how we actually put the local area energy plans and the plans that people put together into practice and actually make them happen. So thank you. We're now on to poll 3. And what are you trying to achieve with using net zero data? And really here we're looking for a text response, and this will help produce a nice sort of word chart by the end of it. So thank you for that. We'll see how that one goes. And now I'm going to invite Ailey to come on stage and talk to us a little bit more about the API in practice. And I think there's going to be a switch as you're going to start sharing your screen, Ailey, if that's right.
Yeah. Morning, everyone. I'm just going to go through how you might actually interact with the API so you get more of an idea of how it might work. Yeah, as John says, I'll just share my screen now. Hopefully you can all see that okay. So this is the Net Zero Data portal that you'll get access to. You can see here there's some information on your API keys that you generate here. You can see data on how many credits you have left, and just some personal details information there as well. So these API keys are, I think Sandeep mentioned them, they're essentially sort of like a username and password to access the API data. I'm not sure how you guys have used APIs in the past, but I know that Postman is quite a popular option. So I thought I'd show on here how you might access our API data through Postman. So in the headers section, this is where you put in your information, your API key and your API key ID that you get from the portal. And then there is in body section here. That's where you put in the information about the kind of data that you want to return. So the table parameter, that's where you input the data set in particular that you're interested in accessing. So in this case, we're going to look at the non-domestic demand. The filter, that's where you'd filter based on whatever parameters you might want to filter on. So to start with, we're just going to look at Birmingham. It's always important to filter by local authority. And then on top of that, you can add extra filters as you need them, and we'll go through that in a bit after this. The limit is the number of rows that you want to return. So if there's 3 rows, it'll return up to 3 rows in this case because we're limiting it to 3. The columns, if you know in particular which columns you want to return, you can specify them here. If you just want them all, you can leave it as null. And then the order by is, as it stands, it's how you're ordering it. So because we've limited it by 3 and we're ordering it by annual electricity demand, this is going to give us the top 3 non-domestic buildings ordered on annual electricity demand in Birmingham. The descending, that's just like an SQL convention where if you don't specify, it goes from smallest to biggest. And then if you want the biggest ones first, you put the descending in. And then we just send this to our URL. And hopefully that should generate down here. This is a previous result. So I'll just let that refresh. Here we go. So you can see here how many credits that's used, how many credits I have left now, and we get a download URL. And then that will give us a CSV of the data. Apologies, I don't have Excel on this machine, so it would obviously look a lot nicer if you did. You'd open that up as you do with any other CSV, and you'd see it in tabular format. I'm now just going to show you how you might interact with this on Python, because that's personally how I usually interact with this kind of data, and it's good for spatial data. So it'd be good to be able to show you some spatial results from calling the API. So basically what I've done here is I've written a template function that does what I've just shown you in Postman, but in Python. So these kind of template scripts will be made available to you, so you can use them as you want. Inside the function, it just specifies the URL, it specifies our headers as we looked at. It builds up this information for the body section, which we saw on Postman as well. It then calls that API endpoint, gets that URL that we clicked on, clicks on the URL essentially, and then converts the CSV data into a spatial format. So what's returned from this function, you can run it. I'll run it now. So I'm running it with the same parameters that I just did on Postman. So we're looking in Birmingham in non-domestic demand. We want the top 3 based on annual electricity demand. I'll just run that here. And then we can look at the output of that. And there are 3 results there. Spatially, at this point, this information here is in GeoPandas. I'm not sure how technical everyone on the call is, but essentially that has spatial information in it. So I could save this to GeoJSON, I could save it to GeoPackage, whatever your format of choice is. For now, I'm just going to quickly save it to HTML so we can have a quick look at what we've got as our result. And then saved it here. Open it up. So we can see that in the case of Birmingham, it thinks that the top electricity demands are all in this sort of industrial estate around the Jaguar Castle Bromwich site. So that's quite interesting. It's worked quite well because these are all in one place. So you can now think, well, if this is a high, obviously a very high electricity demand area, maybe we want to look at solar that's in the surrounding area. So to do that, I've done a bit of basic spatial filtering here. So I've just taken the centroid of those 3 points. And then because I know where that is, I can think about looking within a specific buffer of that centroid point, just based on the X and Y coordinates. So I'll show you here. If I want to look within 500 meters of centroid of those 3 points, I create I build up an SQL style query like this that says I want to look for the points where X is in between these 2 values and Y is in between these 2 values. And you can sort of imagine how that would build up a box, and we can look at all the information that's within that box quite easily with the API. So I'm going to have a look at the solar carports that are in that area. And I can just use the same function, but this time I'm looking in the solar carports data set. I've increased the limit because I don't know how many solar carports are in that area. And in this case, the main thing that's limiting the results is the bounding box filter. So it's looking not only for where the local authority is Birmingham, but also for where the X and the Y fit these constraints. So I'll let that one run. And then as before, I'm just going to save that to HTML so we can have a look at it. And then that should have appeared in here. So we can see now very quickly potential solar carport locations around these high demand non-domestics. And you can get information on them. For example, their HV substation and the percentage of headroom at that substation, an estimated generation, and any information that we have available on the type of car park that it is, and that kind of thing. And then as just one final example, you might then want to look at potentially rooftop solar in the surrounding area. And in that case, our rooftop solar data set includes all buildings, and then it sort of marks each one based on its suitability for solar PV. And that's sort of as a red, amber, green rating. So in this case, we probably wouldn't really want to return ones that weren't suitable for solar PV. So we could add in another thing to filter on into our API query. So in this case, you can see that now our filter is also looking for, where the X and Y coordinates are the same as they were last time within that bounding box that we built, but the solar PV suitability also shouldn't be red, and the local authority should be Birmingham. So that's the sort of filter that we're now passing into the API. So we can have a look at the surrounding rooftop solar. This one might take a little bit longer because there's more rooftops than there are car parks, but hopefully not too long. And then I'll just quickly save that one too. Again, I've added a bit of formatting to this save, so it might be a little bit longer. We'll try that out. And yeah, always a bit of tension when you're doing live demos, but hopefully it should appear pretty soon. Whilst that's running up, let's have a look back at this. Okay, I think that's it now. Cool. Open that up. And then, yeah, that formatting that I applied to it was just to highlight the highest capacity rooftop solar. So you can kind of see there's obviously like lots of little rooftops that are potentially suitable, but the big ones are actually just the same as the buildings that had the highest demand, which makes sense because they're big buildings. And then there's also quite a high potential on top of this car park building there. So yeah, it just pretty quickly builds up a picture of the potential in a very particular area, and it's quite quick and relatively easy to filter to that. I'll stop sharing now. Pass back to John.
Great, thanks very much, Ailey. Poll number 4. What data challenges have you faced before when you finding or using data? Again, we're looking for a sort of a few words, and we'll turn that into a word cloud. So if you can be getting on with that, and we will then take a few questions. I think the first question that's sort of come up, which I'll actually sort of ask Sandeep to come in and sort of respond to, is around technical support or documentation and what's available. So Sandeep, do you want to just give a little bit more details of what's available for people to understand what we've got here?
Totally. Yeah, so on our marketplace, netzeromarket.org.uk, there's an API section, and within that API section in the navigation, there's a documentation, developer documentation subsection. Within that, that's that gives you details about the API and how to integrate, but also sample code as well, code examples. And then for each data set, we have the methodology documentation as well, which gives you the schema information, so table descriptions, column names, etc. But we've had some recent feedback to bring kind of that schema and those column names into a single place on the API documentation. So we'll be enhancing the documentation to enable you to get access to the column names in a single place on the marketplace. And then from a support perspective, if you need some guidance or additional support with developing your integration or hooking things up, yeah, we can support and advise and answer questions that you might have when it comes to what might be best in terms of how you develop your integration.
Brilliant, thanks for that. And then there was a question from Malaki from National Grid's Electricity Distribution. I hope I'm pronouncing that name right. Around the question of use it or getting more results, use more credits. So perhaps you can talk a little bit about the way that the credit system works.
Yeah, so the simple answer to that question is yes, it will use more credits for more results that you're returning per query, because each credit it relates to a row of data returned. So the more data you return, the more credits you use. So your queries can be as wide or as broad as you like, but that will obviously use more credits because you'll be returning more data and therefore more rows. But obviously, if you narrow down your query, and the example that Ailey presented in her demonstration, where she talked about the rooftop PV potential and the RAG ratings, if you disregard all of the reds and ambers, for example, you're only interested in greens, that then reduces your result set and therefore the number of rows that you return and therefore the number of credits you use. So the credits are used on a per row basis.
And Sandeep, I think I'm right in saying that the queries will actually tell you how many credits you're going to use beforehand, so you don't suddenly use them all up in one credit.
Yeah,
one
so we do. That's right. So we do have some safety checks built into the API logic. So one of the first checks we do is, do you have enough credits to run this query? If you don't, then we'll provide a response to say you don't have enough credits, and we won't simply just run the query and then hit the limit and then return the results, and therefore you've used up all your credits. We'll do that sanity check beforehand. But whenever you do run a query and return data, we do present an output, or we do present the output that says the number of credits that you've used to run that query and your total number of remaining credits that you have.
Right. Now there's a question actually for Jonathan, if you're still there and wants to come back online, which at least I think it was addressed to you, which was, what data did you use to deploy low carbon technologies on schools? Was it the solar EV potential data?
We were comparing it against solar data, yes. So what we've done is Sandeep's provided us with a sample set of data for the projects that we've looked at, and we used that as the baseline. We then went to the roofs and said, did the roofs work, and is there demand? And again, it changes depending on who's paying for it. If our clients because again, it's that return on investment calculation. So we've sometimes they're smaller to get the return on investment because the demand's not there. So we might not have put as much solar on a roof because as the model might say, because the return on investment for the client might not add up. Does that make sense?
Brilliant. Thanks for that. And helpful clarification. Another question that seems to have been flagged up a little bit is, can we try before we buy?
Sorry, I was on mute then. Yes, so we can make available access to our staging environment and give you a small bank of credits to give you the opportunity to simply try before you buy. So yes, that is something we can do.
Right, and we just had a question come in from Emma, and I guess this one's probably best for Ailey, which is, can the outputs be produced in different formats, either e.g. JSON or CSV?
Yeah, so by standard, the outputs are returned as a CSV. That is the thing that gets downloaded if you just use the download link, and then that's pretty easy to convert into whichever format you want. The sort of template code that we will provide will return a geodata frame if it's using Python, and at that point you can save that in whichever format you'd prefer.
Right, thanks. Another question, probably for Sanjay actually, for Sandeep actually, is why not just use pounds and pence rather than credits?
Yeah, so it was a conscious decision to use credits, primarily to manage sort of the complexities around Ordnance Survey licensing and royalties. So we talked about PSGA membership and licensing in John's intro and in my sort of overview of Net Zero Data. So there are kind of two flavors. So you've got the PSGA way of access, PSGA membership, and then non-PSGA membership. Royalties are payable if you're not a PSGA member. So we've opted for the credit model because if you're a PSGA member, royalties aren't due. So then the number of credits that you would use per row differ to those that are non-PSGA members, because we have to factor in the cost of royalties. We went down to the pounds and pence. The logic to deal with all of that would just get quite messy, and it would become complex from a perspective where we need to try and manage it, but also complex in trying to understand it from your end as well. the credits is just a very simple, cut and dry, black and white way of handling that scenario.
That's great, and of course, because you buy the credits up front, there's sort of no billing afterwards, which
Exactly.
makes life much easier for everyone
That's
as far
right.
as that's concerned. Right now, what was the next question that I've got flagged up? I've lost it. Sorry. Yes, of course. Ian Jones's question, and very dear to my own heart. Are there any plans to incorporate data on existing heat networks and the heat network zones into the data that we're providing?
Yeah, so I think Gordon's kind of started to answer that question in the chat. We do have data on existing heat networks and those that are planned. But specifically around heat zones, we had started some work last calendar year to develop a heat network and heat zones data set, but we paused that because we knew HNDU were developing something and we're going to release something. So yeah, I'm very keen on having conversations with people who have an interest in heat networks and heat zones. So yeah, Ian, I'd probably reach out to you after this webinar if that's okay with you, and we can get into the details.
And I'm not sure if this is for you, Sandeep, or for Ailey, but can you use this API to get an idea of the public and private EV charging infrastructure? And I think particularly the question there is around the private EV charging infrastructure, and that's from Chris Lorch.
I can have a go at answering it, and Ailey, you might have to keep me honest, but yeah, private EV infrastructure is very difficult to try and get data on. So the data that we have is primarily public EV infrastructure. You know, one of our sort of since the sort of decommissioning of the National Charge Point Registry, you know, ZapMap has kind of become the de facto sort of source of public charge point and public EV infrastructure data. Yeah, so that's what we use. That's where we pull our data from primarily. But yeah, like I said, the private EV infrastructure data is, yeah, I don't think it exists publicly anyway.
Right, thanks. And did you want to add to that, Ailey? Okay.
No, I think that covers it.
Yeah. Right, and there's always and I think this may well be just the final question, and we'll endeavour to answer any other questions in the chat or follow up with you afterwards. But a great question from sort of Cara really, which is when will additional features be included, like additional technology opportunities, and so really, what are our plans for upgrading this moving forwards?
Yeah, so with that question, so we've got a roadmap, you know, for enhancing the data, but also improving the API as well. So as and when, and that roadmap is driven by sort of customer needs, market needs, and like what's happening in the world of net zero and energy. So it's difficult to say when things will be included, but we do react to like regulation changes, for example, and new technologies that are coming up. So yeah, I guess I feel like I'm responding like a politician now by not quite answering the question without answering it. So yes, what I would say is, yeah, we do have a roadmap, we do enhance the data sets, and we do bring up additional features and additional insights into the data as and when required. But Cara, if you have anything specific that you would like, yeah, I'd very much like to have a chat with you around that, because, you know, any insights or any requirements you have can then inform our roadmap, because there might be something in our backlog that your needs might just help, you know, help with the prioritization.
Great, thanks for that, Sandeep. And yeah, just to stress to anyone, you know, we develop data sets that people tell us they want. And so, you know, the more feedback we get on this, the more likely we are to be developing data sets that actually sort of meet your particular needs. So I think in the interest of finishing on time, we'll stop answering questions at that point and start finishing up. So firstly, I'd like to say a huge thank you to all our speakers, but particularly to Jonathan and Jody for coming and sharing their experience of using the Net Zero Data API in practice. Thank you all for attending. I hope you found something useful here, and I hope you found it in the session informative. And please do sort of look on the website and browse. Obviously, we'd love you to be buying our data, but more particularly also sort of come back to us if there's anything that's not clear, and you've got any queries. On the website, also on the sort of slide at the moment, there's the information address that you can sort of connect to us to and sort of ask any queries. So please do sort of come and join us. We'll be posting a recording online, and do explore the functionality in more detail. Thanks all once again, and goodbye for now.